Hello. In this video, we're going to do a quick reflections review. Okay, so in our first problem, we want to reflect the point A over the x-axis. A is at the point -4, -3. Remember, if we're talking about the x-axis, that's the horizontal line right here. That's the x-axis. Okay. You do want to know the coordinate notation or the algebraic rule for these things, but when you're just trying to go from the pre-image to the image and you're doing the reflections, all you need to do is count how far away are we from the axis of symmetry. That's what we're calling the x-axis this time because that's what we're trying to reflect over. So here, point A is 1, 2, 3 points away from the x-axis. So we just need to count 3 units on the other side, 1, 2, 3, and A prime is going to end up at -4, +3. If you want to think about the coordinate notation, think about how x, y, your x coordinate stayed the same, but your y coordinate changed signs. Let's talk about point B going over the y-axis. Remember that the y-axis runs vertically. So we have the y-axis right there. And the process is the same. So B is starting here at 1, 2. And we just need to count how far away we are from the axis of symmetry. Since the axis of symmetry is the y-axis, we just need to count the 1 unit. So, I'm sorry, we just need to count the units. In this case, it's 1. So we need to count 1 on the other side. And now B prime will be at -1, 2. This is similar to the x-axis. It's just now, when we're looking at the rule, the x value changed and y stayed the same. So when it comes to reflections, the general idea is just count how far away you are from that axis of symmetry. Let's see another example. Now we want to reflect point A over the line x = 2. The thing we have to be careful about is what is the line x = 2. When it comes to the line x = 2, I do not care what the y value is. We do not care what the y value is. We need x to be 2. So y can be 0, or y can be 5, or y can be -4, as long as x is stationed at 2. So the line x = 2 is a vertical line. We want to count how far A is from this line. We're going to have to go off the graph a little bit on this one, okay? A was at -4, -3 again. Okay. And we're just counting how far away are we from this line. We're 1, 2, 3, 4, 5, 6 units away from 2. Okay, so we need to count 6 on the other side. So we're going off the grid a little bit, but we need to go 1, 2, 3, 4, 5, 6 to put us here at 8, -3. Notice that this line x = 2 is parallel to the y-axis, and in both cases your x coordinate, I'm sorry, in both cases your y coordinate stayed the same. Okay. When we're reflecting across the line x = 2 or y = -1, we're not going to ask you for the rule. You just need to make sure you can go both directions, forward and backwards. Okay. Here, we're going to reflect the point B across the line y = -1. This is going to be a horizontal line. I don't care what x is as long as y is -1. So we have this, okay? And as we've been doing, we just need to count how far away we are from the axis of reflection, or axis of symmetry. B was originally at 1, 2. Okay. We are 1, 2, 3 units away from the line of reflection or axis of symmetry. So we just need to count 1, 2, 3 units on the other side. And this is going to put B prime at 1, -4. Reflections are just about counting. We have one last example, and this one's kind of the exception. Point A was reflected over the line of y equals x, and now has the coordinates of 4, 1. What was the pre-image of A? So we're going across the line y equals x now, and we're actually starting with the image and going backwards. So we want to know where A started from, but we know that A prime is over here at 4, 1. Now we say that reflections are about counting, and this is still the same thing, okay? But we're counting how far away we are from the line of reflection, from the axis of symmetry, but this is a diagonal. And it's not really easy to count on that diagonal because it's not as simple as going, oh, we're 1.5 spaces. We have to do triangles with that. So this would be the one time where I would say, let's memorize the rule. If we're going across the line y equals x, this rule is going to go xy goes to yx. When you're reflecting across the line y equals x, x and y just flip spots. So here, if we started at, if we end at 4, 1, we had to have started at 1, 4. And let's see this on the graph. Okay. If we go over 1 and up 4 and draw our line to our axis of symmetry, we can kind of see that we have that reflection there. Okay. So, oops, not A prime, A. Okay. I hope this clears up any misconceptions that you guys might have had. If you have any questions, please reach out to us.